So in this video, we're going to talk about how to use the unit circle to evaluate trig functions of angles. So the unit circle is a circle of radius 1 that has its center at the origin. The unit circle can be used to help us find the measures of angles that are in standard position. So you can see here we have an image of a unit circle. Notice it has a center at the origin and it has a radius of 1. So an angle in standard position will have its vertex at the origin, its initial side will be the positive x-axis, and then its terminal side will be rotated counterclockwise if it's a positive angle. The terminal side will be rotated clockwise if it's a negative angle. So the reason we're talking about this is because you can put an angle in standard position on the unit circle, and then something really interesting will happen. If we have an angle theta, like shown here, that's in standard position on the unit circle, the intersection of the terminal side and the unit circle will have the coordinates x, y. And what's interesting about these coordinates x, y is that x tells us the value of the cosine of theta, y tells us the value of the sine theta. And then if we take the ratio of y over x, that's going to equal the tangent of theta. Because what happens is this orange triangle that we draw in here that's formed, that's actually going to be a right triangle. So what's going to happen is sometimes these angles will form special right triangles that you heard about back in geometry. So you can have a 45, 45, 90 triangle. So the sides will be x, x, and x times the square root of 2. Or you can have a 30, 60, 90 triangle where the sides will be x, x squared of 3, and 2x. So let's try an example. So here we have a 30-degree angle. You can see the angle is in standard position and it's on our unit circle. So what is the cosine of 30 and what is the tangent of 30? Well, the cosine, we just have to look at the x-coordinate, right? So the x-coordinate is the square root of 3 over 2. So that means that cosine of theta is going to be the square root of 3 over 2. Now let's figure out the tangent of 30. So the tangent of 30 is going to be the ratio y over x. So we take the y-coordinate, which is 1/2, and we put it over the x-coordinate, which is the square root of 3 over 2. Well, remember, when we divide by a fraction, we actually multiply by the reciprocal, so let's go ahead and do that. So when we do that, we end up getting 1 over the square root of 3. Well, we don't like leaving square roots in the denominator, so what we're going to do is we're going to rationalize the denominator by multiplying with the square root of 3 over the square root of 3. So this is going to turn into the square root of 3 over 3. So we have now the tangent of 30 is equal to the square root of 3 over 3. Okay, so we have our two values, the cosine and the tangent. So there's also this idea of coterminal angles. So what happens is an angle in standard position can have the same terminal side as another angle. Because what will happen is if we take and keep rotating any measure of 360, okay, so in the counterclockwise direction for positive or a clockwise direction for negative, we can get an angle that has the same terminal side. So that's why they're called coterminal angles. They have the same terminal side. So for example, you can see this 30-degree angle and this angle that measures 390 degrees because we went all the way around and then back to here. They're coterminal angles because they have the same terminal side. And that's also, you can see they have the relationship 30 plus 360 equals 390. So we also have this very important concept of reference angles. Okay, so let's call our reference angles alpha. What alpha is the smallest positive acute angle formed by the terminal side of the angle and the horizontal axis. So for an angle that measures 0 or greater than 360, you need to first find the coterminal angle by adding or subtracting a multiple of 360. I know these definitions may be a little confusing right now, but I promise when we get to an example, it'll make more sense. So what the idea here is, like if we have an angle that has a terminal side in quadrant 1, the reference angle alpha is equal to the angle itself, okay? Alpha equals theta. If we have an angle that has its terminal side in quadrant 2, we have to use this formula to find alpha because you see alpha is the smallest angle formed with the x-axis. So it's going to be the angle on this side. So you can see theta and alpha in this case are supplementary. That's why alpha equals pi minus theta. Okay, or 180 minus theta if you're in degrees. If we go down to quadrant 3, what'll happen is you see theta is here, right? So theta has a terminal side in quadrant 3, and then alpha will be this angle formed right here. Okay, so you can see here alpha is going to be like from here to here is 180, and then we have this little piece which is alpha. So theta minus 180 is going to be alpha. And then quadrant 4, you see, okay, terminal side in quadrant 4 means we went all the way here. So it's actually alpha is just what remains to form 360, right? What remains to form one entire rotation. So alpha is going to equal 2 pi minus theta. So let's get into some examples, okay? So how does this even work? So you can see questions that say, like, what is the reference angle of an angle that measures negative 217 degrees? Well, negative 217 degrees is not between 0 and 360, right? Because we're looking for angles that are between 0 and 360. So we need to first make an adjustment. So what we're going to do is we're going to find the coterminal angle. Since this is negative, what I'm going to do is I'm going to add a multiple of 360, okay? Or you can think about it, you keep adding 360 until you get an angle that's between 0 and 360. So I'm going to just go ahead and start by adding 360. So when I add 360, I get negative 217 plus 360, and then that gives me 143 degrees. Okay, so now I need to figure out which of these four formulas to use, right? What quadrant is 143 degrees going to wind up in? Well, the way you can think about the quadrants is from here, it's 0 to 90, right? So if I'm in quadrant 1, my angle measures between 0 and 90. From here, well, this is 180. If I'm in quadrant 2, the angle measures between 90 and 180. Here is 270. So if I'm in quadrant 3, the angle measures between 180 and 270. If I'm in quadrant 4, the angle is between 270 and 360. Okay, so what will actually happen if we have a 143 degree angle is that it's going to be in quadrant 2. Okay, so we know that this angle is going to have a terminal side in quadrant 2, so that means I need to use this formula right here. So in order to find the reference angle, I need to do alpha equals 180 minus 143. Okay, so that means that alpha equals, I do 180 minus 143, and that gives me 37 degrees. Okay, so that's the reference angle for an angle that measures negative 217 degrees. So now let's talk about the unit circle in a little more detail. So I told you that if we have an angle in standard position with its terminal side on the unit circle, the intersection of the terminal side and the unit circle, the coordinates tell us the value of cosine and sine, right? So you can think about these coordinates as being like cosine theta, comma, sine theta. And if you have trouble remembering, remember it goes in alphabetical order. So all the kind of special angles like 30, 45, 60, and then the ones that correspond to that are labeled on the unit circles. This is a completely filled in unit circle, and you can use these to find the exact values of cosine, sine, and tangent for these angles. So let's now use the unit circle to determine the values of the following trig functions. So we have cosine 30, tangent 60, and cosecant 60. So cosine 30, okay, we're just going to go to our unit circle. Remember, cosine is going to be the x value, right? Because it's cosine, comma, sine. So we go to 30 degrees, which is right here, and the cosine is going to be square root of 3 over 2. I'm just reading the value from the unit circle. Now let's figure out tangent of 60. Okay, tangent of 60, well, 60 is right here, right? So remember, tangent is y over x. So I'm going to do the y coordinate, square root of 3 over 2, over 1/2, okay? So you divide by a fraction, you multiply by the reciprocal. So I have square root of 3 over 2 times 2 over 1. So the 2's cancel, and that just leaves me the square root of 3. So tangent of 60 degrees is the square root of 3. Okay, so I'm just going to circle my answer so you can see what I have. Now we need the cosecant of 60. So cosecant, remember, is one of our reciprocal trig identities. So the cosecant of 60 is going to basically be 1 over the sine of 60. Okay, so to find sine 60, I go to my unit circle, and then look, that y coordinate is sine, right? Sine of 60 degrees is square root of 3 over 2. So the cosecant of 60 is going to be 2 over the square root of 3. Well, once again, we have to rationalize our denominator because we can't leave our radicals in the denominator. So I'm going to multiply by the square root of 3 over square root of 3. So I have 2 square root of 3 over 3. Okay, and that's my cosecant of 60. I have my tangent of 60 and cosine of 30. So also there's this generalization about the signs, okay? So what happens is we can identify the sign of each trig function depending on the quadrant in which the terminal side is. So in quadrant 1, okay, so I'm just going to go ahead and write my mnemonic. The mnemonic is all students take calculus, okay? And we go in counterclockwise direction because that's how we measure angles on the unit circle, right, if they're positive. So what that means is that in quadrant 1, all of the trig functions are positive, okay? In quadrant 2, only sine is going to be positive because if you look at this, notice that all the cosine values are actually negative. So that's why all the tangent values are actually going to be negative also. T in quadrant 3 means that tangent is the only one that's positive because notice that both cosine and sine are always negative. So if you do a negative over a negative, that gives you a positive. And then finally in quadrant 4, that's where cosine is positive, because notice that all of these cosine values are actually positive and the signs are all negative. Okay, so that's the mnemonic. All students take calculus. So if you know the quadrant of the terminal side of an angle, you can tell me this which trig function is going to be positive or negative. Okay, so here it's saying what are the signs of sine of negative 135 and tangent of negative 135? Well, it's always an issue when we don't have an angle that's between 0 and 360, right? If we don't have an angle that's between 0 and 360, we need to find the coterminal angle to figure out what's going on. So to find the coterminal angle, I'm going to take negative 135 and I'm going to add 360 to it. So when I do negative 135 plus 360, that gives me 225. Okay, so remember here's 0, here's 90. Oh, they're already labeled 0, 90, 180, 270, and then this is also 360, right? So if it's 225, that means it's going to be down here in quadrant 3. Well, in quadrant 3, okay, remember if we do our mnemonic, all students take calculus. Quadrant 3, that means tangent is going to be the only one that's positive. So I don't need to find the exact values of sine and cosine. I can already tell you that the sine of negative 135 is going to be negative, okay? And then the tangent is going to be the only trig function that's positive. So the only function that's named in that mnemonic will be the only positive one in that quadrant. So in this problem, it wants us to find the value of the cosecant of 270. So cosecant, remember, once again, it's one of our reciprocal trig functions, okay? So it's going to be 1 over sine of 270. So the sine of 270, remember, all of my values are cosine, comma, sine. Right, so I'm going to look for the y-coordinate at 270, which you can see is negative 1. So this is going to be 1 over negative 1, which is equal to negative 1.